Hello, ladies and gentlemen, and today we're going to go ahead and talk about transformations of graphs. Transformations of graphs, and please put this on page 43 of your interactive notebook. So we have 5 basic transformations that we're going to want to do. I will be using the parent graph of the absolute value graph, and that is y equals the absolute value of x. These two lines on either side of x stand for the absolute value. We will be investigating this parent graph soon, but we want to translate this or transform this different ways by moving it left, moving it right, moving it up, moving it down, and then reflecting, or what we could say flipping it. Okay, so we're going to go ahead and try this. So ladies and gentlemen, on the first graph that I give you, we're going to move this graph to the left. Now whenever we move to the left or to the right, I want y'all to think opposite. Now when I say think opposite, when I write something down, you're automatically going to want to think one direction. But honestly, if you start to think opposite, you'll understand what I'm saying. Okay? So let me write the first equation. It's going to be y equals the absolute value of x plus 5. Okay? This plus 5 will move the graph to the left 5 units. Now, what that means is every point, every special point, everything will be moved 5 units to the left. So I'm going to grab my graph and move it 1, 2, 3, 4, 5. So, please draw this as y equals the absolute value of x plus 5. A lot of people think that when you add 5, you're going to go to the right 5, but that's why I'm saying think opposite. Remember to pause the video or rewind anytime you need to. The next thing we're going to do is we're going to move right. So I'll write the equation y equals the absolute value of x minus 3. And once again, I want you to think opposite, because the minus 3 almost seems like we're going to go to the left 3. But we're actually going to move our graph to the right 3 units. So here we go. 1, 2, 3. And this is what our graph is going to look like when it's y equals the absolute value of x minus 3. The next graph we're going to do is we're going to move our graphs up. Now for this one, you don't want to think opposite. It actually looks like what you think. For instance, I'm going to write the equation y equals the absolute value of x plus 4. This plus 4 outside of the absolute value is going to move our graph up 4 units. So here I go. Sorry. Ready? 1, 2, 3, 4. And this is a absolute value of x plus 4, shifted up 4 units. To move a graph down, you guessed it, we're going to write y equals the absolute value of x minus 6. We're going to subtract 6 from the absolute value, and that'll move it down 6 units. Let's go ahead and see what that's going to look like. 1, 2, 3, 4, 5, 6. Notice the graph doesn't change. The only thing that changes is the position that we have the graph in. Okay. And last but not least, ladies and gentlemen, is a reflect or flip. To do this, ladies and gentlemen, we're going to take our absolute value graph and we're going to put a negative in the front of the absolute value. What this is going to do, ladies and gentlemen, is it's going to take our graph, and let me grab it real quick. And I am going to flip it. Sorry. Sorry. Let me redo this. I'm just going to take this graph and flip it upside down. That's what I should have done at the very beginning. And I'll move it. And this is what the graph's going to look like if it has a negative in the front. It just flips it over the x-axis. Now, one thing I haven't done, and I'm going to do this for our next example, is sometimes we have this y equals, right? But we don't always have to have y equals. Sometimes, ladies and gentlemen, we can have f of x, which means the same thing as y. F of x equals, and look what I'm going to do. X minus 3 plus 2. Okay? When I put f of x equals x minus 3 plus 2, the absolute value of x minus 3 plus 2, there are going to be two things going to happen. The first thing, I'm going to move to the right 3 units because I got to think opposite, and then I'm going to go up 2 units. So, let's practice. Ready? I'm going to go to the right 3 units, 1, 2, 3, and I'm going to go up 2 units, 1, 2. So this is what the graph would look like if it had not only a horizontal shift, but a vertical shift. Let's practice one more. Let's say I gave you the function f of x equals the opposite of the absolute value of x. Well, you know what? I'm not going to do that yet. Hold on. We'll do that maybe in class. Let's do the absolute value of x plus 3 plus 4. Remember, f of x means the same thing as y. This will move our graph 3 units to the left because we're going to think opposite, and we're going to move it up 4 units. So, let's practice this. 1, 2, 3 to the left, and 1, 2, 3, 4 up. All right. Let's do another example. And again, feel free to pause or rewind the video if you need to. I got f of x is going to equal the opposite of the absolute value of x minus 3. This time the number's outside the absolute value. Here we're going to do a reflection and we're going to move it down 3 units. So here I go. I'm going to reflect it about the x-axis. So I'm essentially turning it upside down. Okay? And then I'm going to move it down 3 units. Ready? 1, 2, 3. And that would be our final answer. I want you to try this example on your own. Ready? F of x is going to equal the absolute value of x plus 5 minus 2. Pause the video, and then I'll go over the answer. The answer for this, first of all, since the plus 5 is inside the absolute value, I'm going to go to the left 5 units. The minus 2 is outside. That tells me I'm going to go down 2 units. So let's grab my graph. And let's go 1, 2, 3, 4, 5 to the left, and 1, 2, down 2 units. Okay? We'll do some more examples in class, and of course we'll have some homework we'll be practicing, and might even have a gallery walk on this, or maybe we're going to do a cakewalk. All right, I'll see you soon, y'all. Thank you for paying attention.